in meteorology. I really want you to know there's lots of schools here in Florida that offer degrees in meteorology. So it's something to think about. It's a good data analysis job. It's not going away. The weather's always changing. People are always there trying to figure out and predict what's happening with the weather. So in a lot of the science and the math is done. You just need to look at it, interpret it, and just be responsible in the data entry of it. So this is the problem you're supposed to be reading. Hurricane Wilma came before most of you were born in 2005. On record, it was the strongest Atlantic tropical cyclone. It reached 185 miles per hour, which is like way higher than what we've seen recently. And the name was Wilma. So did that come early in the hurricane season, or did that come late in the hurricane season? It's late because it's a W. You guys know the storms are named alphabetically. So if it was named something like Albert or Andrew or Doug or Elizabeth, those are early in that hurricane season. W is late in the hurricane season. So we had a very strong hurricane late in the season. And so this square root function is really how we're measuring air pressure based on wind velocity. So this is saying if the velocity is 54.5 meters per second, what would the air pressure be? So today we're taking a break from graphing, we're solving equations. These are the steps we're going to use today when we start solving equations. They plugged in the 54.5. What did they do after they plugged in 54.5, Tyler? From here to here, how did this go from 54 to 8? Let's look at the red letters. See the 6.3 in front? That gets divided on both sides. How did it go from 8.65 to have this little 2 here? They're trying to cancel a radical. To cancel a square root, you do a power of 2. To cancel a cube root, you do a power of 3. To cancel a fourth root, you do a power of 4. So 8.6 squared, 74.8, subtracted 1,013 divided by 1, and here's our air pressure. Has anybody ever heard of a millibar? That's a unit of measure talking about air pressure. Typically, we feel about 1,000 millibars. So evidently, the center of this hurricane was very low pressure. I don't know if that's what allows the wind to move so quickly, is the low pressure. I don't know which caused which. I'm not a meteorologist, but I'm very interested knowing that it's lower than what we usually experience. I guess that's all I have to say. So this is the answer to bell work, this blue sentence here. The pressure at the center of this very fast-moving hurricane was 938. I don't know if it was moving fast, it was spinning fast. Yes? I also want to know that, Riddick. I'm with you, but I don't know. I'd have to Google it. This is what I really think right now, and I wonder how many of you guys are on board with me. It might be very low pressure here in the middle, but higher pressure on the outside. Like maybe the air pressure is just changing within that, and maybe because it's talking about the very center. You know how they say it's really still at the center? Maybe it's just low pressure there, but the outside's high pressure, and that's what's creating all of that. Maybe I don't know. But if you're interested in it, you should consider studying meteorology. Pick something and go with it instead of just being undecided for years in college. Just find something interesting. Go with it. Verdict, the meteorologist. Oh, yes, awesome. Yeah, cool. Very cool. All right, so I just want to go through the graphs from yesterday. we're gonna get into solving equations today. This is the assignment, but you guys, I'm gonna do evens in class. So far today, I have not gotten to 20. I've only gotten to 14. And you don't have to do 16, 18, and 20. You just stop where I stop. You have to do all the evens I do, and you have to do odds. So if you want to write that down, go right ahead and then open your books at 447 so I can see that you tried graphing yesterday. The third graph was the most difficult. The fourth graph was the easiest. Yeah, what? Oh, 448. You're right, cousin. It's 448. Keep it real. Keep it real. 448. Don't confuse people. I've been confusing people all day with that, actually. Here's 21. That looks nice. Alright, be quiet. Everybody be quiet while I talk about 26 for a little while. The reason I want to talk about 26 is because I got very insecure when I plotted my points. I got scared because I had my center point, and then my next point was way down here. Most of our square root graphs have been pretty flat. I would have thought the next point would be right here, and then the next one would be right here. It should be like this, right? And this one was sliding down like really quickly, so I had to go back and check my work. I thought I messed up. Sure enough, it's right. Why does this one have such a steep slide, whereas the majority is just kind of like little short intervals on the y-axis? It's the 5. It's a stretch. It's the 5. It's the 5. You guys hear that? Once I went back and I saw, oh yes, there's a 5 here. That means instead of over 1, down 1, I'm going over 1, down 5. I realized that in fact the math came out right, and this picture has a stretch of 5 units. So you should be thinking, does your graph match what you know about transformations, and checking things out like that. Okay? So here's 26. On the next page, 19 was the most difficult one. Most people stopped and quit at 19. I really want you guys to do 21. 19 is harder than the test. 21 is more of a test question. So let's flip to 464. And I want everybody who quit and didn't do this, I want everyone doing 21 while I'm walking around, because 21 is the test question.
Not bad. Yeah, 19. 21 simple. Right? There's not even any stretch. Well, I have negative 3 0. Negative,
I have
is that negative
2 0.
4? Negative 4, negative 2.
Nope. The only numbers we have the same that are is negative 3 0. It's not.
I think it's the same. Practically the same.
I got something similar.
I don't know. I don't know what we did.
Well, did you do the whole thing? Oh, I didn't shoot. I didn't want to break the school starts.
So did you do any? You did the vertical, not the vertical. You did the horizontal stretch, right?
Yeah.
Technically,
So you do the fences and then multiply 2 times whatever.
I distributed it first in terms of next. That's what I did. Then I went back and I said, hey, 4 goes up to 2. Left 6. I don't know.
Oh, I see. I know the old
So G 7. 14.
Alright, and then here's 19, that really challenging one. Any questions on the assignment?
Why didn't you call 4 numbers? Or do you mean all 6 numbers?
I just ran out of room.
So in that situation, what you want to do is you want to do parentheses first. You don't want to distribute.
Either way. Whichever way you
Because I
prefer.
distributed and we got different stuff.
Yeah. It should come out the same. What number do you want me to start?
Thank you.
No, what exercise? I put in either 7 over 2 or 3.5. Alright, Michael, -1. So I'm gonna do, and you did distribute?
I distributed.
I would get x plus 3 is -1/2. Subtract 3. -1/2 minus 3 is -3.5. No, that's what I'm gonna put in the table. Now we're gonna do the cube root. -3.5
I'm saying is I distributed it to
Yeah, you're fine. It doesn't matter.
2x plus 6.
Yeah. The cube root of 2x plus this. So that would be 2 times 10 to the 3.5 plus 6. That's negative 7 plus 6. That's negative 1. Now, he didn't come up with 3.5, so I guess he doesn't
When I did it, I just made it go left and 6 and stretch it to.
Okay.
I didn't plug in the X. So. So you're not going to distribute, you're going to solve it twice.
All right. Okay. All right. Page 473 now. A lot of times I will write down steps because I know you guys like to have steps in your notebook. And I know you like to write the steps because it helps you remember them. Now these 3 steps on page 473 for this new section, they're pretty basic. I'm going to tell you what I would write down if I was taking notes in my notebook. These are on how to solve radical equations. Now, this will be a vocabulary word on your test. A radical equation is just an equation that has a variable under the radical bar. So sometimes people think any equation ever with a square root or a cube root is called a radical equation, but that's not true. It's got to have the variable in the radical bar. Okay? So contains a radical that has a variable in the radicand. Now here are the 3 steps that we're going to look at for solving these equations today. I really think that you'll find the majority of these equations pretty straightforward. You're going to feel like, yes, you know how to do it. It's going to be good. Step 1, isolate the radical. So if I was writing steps down, I would have just written that. It should be said it's not always necessary. Sometimes the radical is already isolated. So the first few problems in your assignment, step 1's already done. So if necessary, get the radical alone. Step 2, raise both sides to the same exponent in order to eliminate the radical. Raise both sides to an exponent, okay? What will happen is the exponent cancels the radical and you solve what you're left with. Sometimes you're left with a linear, quadratic, or other polynomial. So sometimes you're going to have to factor it. You'll have to use some other polynomial method of solving. Sometimes they'll be very basic linear equations. So whatever's left, solve using any techniques. Wrong one. Solve using any techniques that we've used so far. The other thing I want to highlight about these steps is that you do have to check your solutions. Extraneous solutions will exist. Normally, if you get a quadratic and you factor it and you get 2 answers, there's a chance that one of those have to be thrown away. So an extraneous solution means you solve everything correctly, you do every step how you're supposed to. You get an answer out, you plug it back in, and it breaks the rule. So I don't typically require students to check, but with this particular type of equation, we have to be careful and check. When you're ready, I'm going to leave this here for a little while. Let those of you who like to write steps down, write them down. When you're ready, I'm going to this page. Like I said, I'm doing evens. I'll probably only get to 14. So 16, 18, and 20 we probably will not do. You'll do the odds for homework and you'll do the evens in class so you can ask questions and figure it out. I'll get started on those in just a moment.
How fast you go. So. Certain things you can I don't have a brain. I should message.
So 70 or 436. Or 77, same shit. The same thing. 20, 4. Wait, read this. Yeah. Alright, cool. So you got this. 1 through 20. 1 through 20 odds. You she doesn't even get lace. It's like home. I didn't want to go as small as possible. Yeah, I don't think they're well. No, they have to wait a spot. Oh, you're right.
Alright, I'm gonna start with some evens here. Number two. Oh man, no big deal. Like I said, I think you'll find these kind of a nice refreshing change up until like the second half. Up until the second half, these are kind of nice. Okay. So number two, step one is done. There's nothing here in front. There's nothing behind the radical. It's just a radical. So we're gonna raise both sides to a power of two, and that's gonna cancel the square root bar out of the equation. So my 8 turns to 64, and the square root bar is gone. Okay. And now this is just a regular linear equation, algebra 1. You just subtract the 10, divide by 3, call it a day. So some of you guys are going to like these a lot more than some of the other work we've been doing. And we get the answer. X is 24. No, it's not 24, it's 18. Look at that. Every power. X is 18, you got it. You did it all by himself. There we go. Moving on to number 4. Now notice, number 4 is not a square root, it is a cube root. And then later below here, I think there's a 4th root. You have to pay attention to what the index is, okay? So in number 4, this little guy is not isolated. So step 1, we have to isolate the radical. So I would add 10 to both sides first. The cube root of x is 3. That's the isolate bit. Now, since it's a 3rd root, I'll raise both sides of this equation to a power of 3. This is going to give me x is 27. 3 times 3 times 3, 27. X is 27. Yeah, I'm doing. Well, you have to do all the evens I'm doing in class. And then you have to do the odds, yeah. Any questions on number 4? Are we good with number 4? Yeah, I would check it. I do until it gets more complicated. I just do a mental check. Okay, so you don't have to show that. But I will do like, oh, what's the cube root of 27? 3 minus 10, negative 7. Now, the real alert for a check is an even root. Okay, with even roots, I'm concerned about negative numbers. So odd roots that not typically extraneous, but with the square roots and the 4th roots, be careful to check those. Alright, now a lot of people wanted me to do 5 last class. I'm supposed to do evens, but are there any requests for 5? Should I go ahead and do 5? The big question about 5 is, should I divide negative 2 first, or should I subtract 13? Subtract 13 first. Alright, so I cancel out the 13. This is multiplication here. I'll do the opposite of multiply and I'll divide. And now I have a positive 12. Question so far? Now this is a square root, so I will cancel the radical with a power of 2. So this is 24x equals 144. Divide 24. And x is 6. So if you're working ahead, you can go back to 5 and check it for the 6. Number 6. A lot of students will shy away from the fractions. Just use your calculator, guys. Know your fraction button. Get that done. I'm going to show it by hand because I don't mind doing the fraction work, but you have full permission to put the fraction in your calculator and let it simplify it for you. I'll add 2/3 over. The square root of 2x is 2/3, and then we have to square a fraction. power of 2 on both sides. Now 2x is 4 over 9. Just do the top. 2 times 2 is 4. Do the bottom. 3 times 3 is 9. No big deal. Now I'll have to divide by 2, and this is where, I might lose some of you. Divide by 2. So this is x is 4/9 divided by 2 over 1. You can show it as a complex fraction and then put it in your calculator. Or if you do it by hand, the old school division side, 2 over 1. I don't divide fractions. Multiply by their reciprocal. So that's 4/9 times 1 over 2. So that's 4 over 18, which I would reduce to 2/9. Multiply by the reciprocal. You change flip, yeah. So 6 is 2/9. Please, if the problem does not start with a decimal, don't end with a decimal. Leave simple fraction form here. Okay, shall I go to 8 next? Or yeah, I will give you a moment, and then we will do 8, and then we have to get through 14 no matter what.
I want to keep walking in front of the camera. No, I keep walking in front of the camera. There's a couple of things where me smiling. 3:15. I'm ready to go.
And I'm erasing everything so I can see 8, and I had to mark down 8. I don't know how you guys are doing this. You should do it on a book paper. But maybe it's easier for you to write small than my tablet. I love doing math on paper and pencil. I'm really envious. Alright, here we go, number 8. Alright, let's subtract 10 first. Leaving 1/5 times the cube root of 3x is -2. How do I get rid of 1/5? I'll multiply by the reciprocal. 5 over 1, 5 over 1. That will mean the cube root of 3x is -10. The reciprocal gets rid of that fraction in front. Alright, to cancel a cube root, I'll do a little 3. Exponent of 3 on both sides. I'm at 3x is -1000. Divide by 3. And I'm going to leave this as a fraction. -1000 over 3. I'm not going to make it a decimal. Well, it's equivalent, but this fraction's a little better. Okay, I'll take it. I'll take it. That's precise. What we don't want to do is write 0.3.
Yeah. The second one. Started as a fraction.
And big ideas what? Because it's a decimal that goes on forever, they'll require a fraction on there. Ariel, I'm skipping at 14. This is the last one I'm doing.
Wait, can you do 10?
No, she's picking up 14.
Yeah. Maybe I do all of them. 10 is the first time for the evens anyway that I see a fourth root. That'll change things a little bit. I'm going to add 13 over. I have the fourth root of 4x is negative 2. Wait just a second. This to me looks wrong. So I'm going to bet if I continue through the steps, I'm going to find an extraneous solution. This is a contradiction. An even root should not have a negative result. Okay? So I'm going to continue, and when I check my answer, I bet it's going to come out false. So this is a caution. You can actually stop here. I already know it's not going to work. You can actually stop here, but I'm going to keep going and show you, like, if you didn't notice it, what you would do. So this is 4x equals 16, and it's right there that that things get lost. People forget that this is a problem. So it comes out that x is 4. Well, let's check it. Let's check it. What is the fourth root of 4? What is the fourth root of 6?
So what was the answer there? Just no real solution.
No real solution. Juliana, did you do 10 yet? Did you notice that it's no solution?
Swear to God. I said swear to God.
That's it. Listen, the process results in an answer. It's a sign that honestly our process is flawed. Right here, I knew that this wasn't going to work. But if you go through the steps, it appears there's a good answer. When you plug it in, you actually get a negative 11 on the left and a positive and a negative 15 on the right. They don't actually work. So this is what's called an extraneous solution. You really just have to be careful with the even roots. For cube roots, typically not an issue, but with even roots, be really careful. This one's called extraneous. I'm going to put a line through it because it's not going to work. I can't plug it in.
Good job checking.
Of
I didn't check.
What will happen is, well, for instance, the square root, the hurricane one. Okay. Let's say we put a velocity in, and then solve it, check it, it doesn't work. Then something was wrong in that data. Either the instrument measuring the velocity was wrong, or it's off the model that we have created for hurricanes. It's a brand new type of storm. You know what I mean? It doesn't fall into that scientific model anymore. So that makes you question either the measurement that you put in. Did you get the data wrong, or is this something different than what we thought it was? It's not a hurricane. It's a brand new thing. You know what I mean? Alright, I gotta go 14 because this one's different. Starting with the second half, you now have a binomial or an expression on one side of the equation, and most people will do this wrong, even though they're very competent and good at math. We'll make a mistake here. When I square both sides, it's reasonable to write down x squared minus 100. But don't do that. When you square a binomial, you have to actually side by side FOIL this. Okay? So I'm going to put another caution note right here. Caution, you have to do 2 sets of parentheses. Do a first, outer, inner, last, or it's not going to come out right. Elijah, did you get to 14?
No, I got really confused on 13.
Hey, the word problem? Oh, yeah. Oh, okay. Yeah, no. Yeah, so do 14 with me, and that's going to help you. Okay, so I have to do x times x times negative 10, 10 times 10. And now I'm working with a quadratic that has to be factored and solved. So I have to go back to my factoring skills to finish this problem up. I don't know how you guys are feeling. Yeah, factoring happens every chapter of the book. Can't get away from everything. Alright, I'm doing what multiplies to 100 and adds to negative 29. Okay, it's 25 and 4. I don't know what I just did.